Alright you guys, I've been working on my phase converter. I got to upgrade the capacity of the phase converter. Right now I got 6 horsepower phase converter, and I have another identical motor. So it'll be 12 horsepower once I add in the second motor. And I just want to show you guys what I bought to run the phase converter. Let me go handheld. I'll show you what I've been working on today. Alright, well, there it is, and it is a starting panel for the phase converter. Now, I purchased this from North American Phase Converter, and this is my second one. The 6 horse one that runs my shop is also from North American Phase Converter. Good bunch of folks. So let me show you what the deal is here. Terminal block for input power, and there is a contactor relay. When you turn it on, I'm going to run this longer. This is the on-off button. It's actually in the panel. There's nothing behind it. It just clips on. So input power. This is the main contactor relay. When you turn it on, this is what energizes the rotary phase converter or idler motor, whatever you want to call it. You got some capacitors here. So the black capacitors, 1, 2, 3, these are start capacitors, okay? And these are run capacitors. So the start capacitors get the rotary phase converter motor running, and then these balance out the other phases that's being generated. I think this is one phase, and this is the other phase. But those are for balancing, and those are for starting. So what we got down here, like I said, this is the main contactor relay. That's the output terminals to the motor, the RPC. That right there, that's a current sensing relay. That's a, I believe it's called a subco, SUPCO, and that controls this contactor. And that contactor brings in the start capacitors. So this contactor controls the start capacitors, which is controlled by the current sensing relay. It senses the current between what would be the generated leg and one of the incoming legs. It's just a smaller version of this. This is kind of the same thing. But anyhow, this thing is, I already have one of these, and I'll show you that in a minute. This was $275, okay? Now, if you guys know about phase converters, you can run another idler motor and add to your capacity. And essentially that's what I'm doing. So to run another idler motor, what do I need to think about it? What do I need to run another idler motor? Well, I need another contactor, okay, to bring it in to the circuit and cut it out of the circuit. I need, you don't have to use balanced capacitors, but it makes for a smoother running converter. I need these balanced capacitors to up the to add another motor and balance it out, and you might as well have input terminals and output terminals if you're going to make it look professional. And if you're going to make it look professional, you might as well put it in a box, because it's got the conduit knockouts in the cover. So I could have cobbed together because I got contactors used from other places, and I got terminal blocks from different stuff I've taken apart. And I might have had to buy some capacitors. And I've got other control cabinets from other stuff. So I really don't need the 3 start capacitors, and I really don't need the start relay, and I really don't need the current sensing relay. But I already have one of these. I'm going to put it next to the one I got currently existing. And what I'm going to do is, yeah, it's just going to sit next to it. It's going to look the same. It doesn't have to, but it's just going to be a way I spent my money to have something up and running, and instead of cobbing something together and looking like, I mean, it would look professional, of course, but I just think there's something to be said about spending a little bit of money and having 2 identical phase converter boxes and having the same balanced capacitors and the same relays. And I've had a problem. I had a leaking capacitor, and I called American Rotary, and they sent me a new one free of charge. That was cool. So yeah, that you get support from these guys pretty well. And let me tell you this. So this enclosure, it's got 4 screws, and then the cover is slotted, and it just kind of goes on the front. Now, this is how my original one is, and I'll show you that in a minute. The new style, they don't make this anymore. They make one where it's like a back plane, a top, and a bottom, like 3 sides, and then the cover is not a flat sheet of steel. The cover kind of wraps around this side and wraps around the other side. So it's a little different box, and I called up North American Phase Converter, and I said, hey guys, it's been like about 2 or 3 years, and I've got one of your phase converter panels, and I know you've changed it, but I want to order another one. Do you have any other boxes of the old style? Just because I'm putting them next to each other. I'm a little obsessive compulsive disorder. I want my stuff to look nice and neat. Do you have another one of the old panels you can build me with the electronics there? And they said, no, we switched. And it was a cold call on the telephone. And actually, they looked me up. They said, oh yeah, you're in our system. I said, I want to buy one. And they said, no, we don't have them. He said, but you know what? Let me contact the company we get them from. And I believe Made in USA. No. Oh, here you go. No, that's not it. Somewhere it says Wiegmann. No, that's not it. But it's a Wiegmann. I've seen it somewhere. I think it's on the back of the cover. Right. Yeah, whatever. Oh yeah. So that's just the box. So long story short, they ordered another one for me. They ordered another enclosure, special order, to build this for me, so I have a matching box. And I called them about it, and they says, "Oh yeah, we can order you one." Or they didn't say they could order me one. They said we can call the company, Wiegmann, I guess, and see if one's still available, or whoever is the retailer, wholesaler, distributor for Wiegmann. I'm like, okay, yeah. And you know what? I let a month lapse. I was doing other stuff. So I called North American Phase Converter back a month later. And I said, hey, this is Doozer. I want to order one of your CP7s, and I was wondering if I could get Did anybody did anybody do like a return? We can has the old style box like a refurbished or something. There says, oh no, we got your name in the computer. We called up and we ordered an old style box enclosure, and they sent it to us. And yeah, we can build one for you with the old box. And I'm like, holy Christmas! It's been a month, and I just kind of fell off the face of the earth. But they didn't take down my credit card number or nothing. I just said I want to order one, and I said let me know, and I didn't hear nothing from them. But when I called back, they says, oh yeah, we got it, we'll build you one. So my hat is totally off to North American phase converter. I mean, these guys, they just went above and beyond. So anyways, I'm gonna hook this up, and I'm gonna take you up in my attic. It's gonna be a little shaky, but I'll show you. Well, I'll show you how I got it down here first. So my lines go up to the attic from my fuse box, and air conditioning, RPC is rotary phase converter, and you can see that's the push button switch. I got a multi-conductor wire, and actually it's for a sprinkler system. Sorry for the shakiness. And that's the button, okay? That's the button for starting the three-phase. Oh, and I think I mentioned, I did hang up the Kearney and Trekker breather vent 2H plane underneath the multi-miller. So that's cool. Alright, so that's how you start the phase converter, right next to my light switches in the shop. And I got that in there, and like I said, and incidentally, that's the circuit breaker for the generated phase, for the phase converter. But anyways, let me show you. We're gonna go up in the attic here. I got the ladder. It is hot like crazy in Doozer's attic. Let me. Alright. So that's kind of what I got. I'm not going to jump up here, I guess you can kind of see. This is my cordless battery drill. So I've got my EMT conduit coming up through the floor. You can kind of see how it is. And I've got some liquid tight flex going to my North American phase converter panel, okay? So that flex comes up from the floor, that's coming out of the top of the fuse box. And that other liquid tight flex goes into the motor, okay? Let me jump up here, what the hey. Forgive the shakiness. Alright. So this is Doozer's attic in the shop. Let me get you. Alright, so that's the current existing phase converter. Like I said, I got two of these Leeson motors, okay? And I got one hooked up, like I said. And this one here is going to be the other one. And I've actually got rubber mounts under that one, and I got a couple other rubber mounts I'm going to put under this one. So I'm trying to zoom in here. I don't know if this is going to pick it up or not. Maybe. But if you notice, the voltage says 190, 380, 50 hertz. Horsepower 5. 3.7 kilowatts. RPM, what is that? 990? So this is a, you would think that this is a weird motor. All right, but it's not as weird as you think, okay? And what I mean by that is, I bought this motor brand new for $10, and I bought the other one the same $10. Now I said 6 horsepower, and the tag clearly says 5. But it also says 190 volts, 50 hertz. This is a European rated motor, okay? And it's the name tag is in 50 hertz. Everything is 1/6 less. So if you multiply the voltage by 1/6, that 190 volts by 1/6, you get 230. If you multiply 50 hertz by 1/6, you get 60. Because the difference between 50 hertz and 60 hertz is like, you know, the fraction 1/6. So whoever was selling these motors, I got these in Syracuse, New York, or somewhere around there. I think it's the Doc Hardware guys. Up in, like, say, Syracuse, New York, or is it Rochester? Maybe it was Rochester. I think Doc Hardware is in Rochester. I got these motors for $10 a piece, and like I said, these things weigh 220 pounds. They're just a beefy motor, and they run virtually silent. And the RPM would be 1200 or 1150 or whatever the slip speed is. But anyways, these things, they're just kick butt, totally awesome for a phase converter. They're heavy, they've got lots of inertia, they're quiet, and the thing is, these are 12-wire motors. So what does that mean? Most motors are 9-wire motor. Okay, at 230 volts, most connections are Y, and 480 volts, the connection is delta. These, because they're 12-wire motors, the 230 volt connection is delta. Most motors, the 230 volt is Y. Now, the delta connection, and like I said, I'm able to use delta connection on 230 volts, which is what, you know, I am here in the shop. Okay, I know a good bit about electricity. And someone with more information might be able to comment on this, but I've had experience that says the delta connection shares the load better between the phases. With your Y connection, you've got the center point, and you're going through 2 coils to generate a phase. The connection between the wires is a coil in delta. It's not like a coil in the center point and a coil. Delta is coil, coil, coil. So I just, through experience, have noticed that any delta wound motor used in an imbalanced condition with electricity imbalanced, I don't mean vibration, I mean where your phases aren't all the same, which is what you have in a rotary phase converter. You're putting in one phase and you're getting out two additional phases, okay? You know, this 230 volt residential power is single phase, coming in on two wires. When you have a generated leg, you have another leg. In between that leg, which is the generated leg, and your line 1 is a phase. That's an added phase, a generated phase. And between that generated leg and the incoming line 2 is the other generated phase. So L1 and L2 coming from the pole, single phase 230 volts is one phase. The motor, the RPC, rotary phase converter, generates another leg, which is two phases. It's between that leg and the first L1, line 1 coming in, and from that generated leg and L2, line 2 coming in. So you have the original L1 and L2, that's one phase. Your generated leg in L1 is another phase. Your generated leg in L2 is another phase, so that's 3. So the delta just seems, in my experience, to share the electricity, the current, better between phases, even if it wasn't rotating. If this was a static transformer, you're not going to a central star point and then coming back. I don't know. I'm probably not explaining this very well. Anyways, I'll stop talking about delta, but North American phase converter. I talked to the gentleman on the phone, and he said all their package deal boxes and motors, they're selling only delta motors, and I thought that was interesting. But no affiliation with North American, but just I love this thing. It's built really well. So I've been showing you what I'm going to show you what I'm doing here. So, oh God, it's hot up here. All right, this box used to be hanging on the wall, and let me kind of back up. If I can, ow, hit my head. I've got it spaced 4 inches off the wall right now, okay? 4 inches off the wall, and there's a reason I did that, okay? So to bring power to different parts of the shop, as you can see, I'm drilling through the floor and I'm putting my conduit down in the floor. And actually, I'm not probably going to use that one. That's dedicated. I guess I'm going to put that to my air compressor. I'm going to drill another one. So the pattern in the box of the circuit panel, I got 4 pieces of conduit coming up there, okay? Basically that pattern, I got the measurement, and I'm using those measurements to drill a pattern up here. So these go straight down into my circuit breaker panel. So to get that piece of conduit, that piece of conduit's like 3.5 feet long or something, you have to shove it down, okay? Shove it down in the floor, and you need clearance, all right? So this is the knee wall. It's like 4 foot. These I put in before the panel, and in this one the panel was kind of anchored to there. I could barely get that one in, and if I put another one in front of it and 2 more next to it, I will not be able, because look at this. See, it comes up, and I got to insert it. Like, see there? That's going into the fitting of the fuse panel down below, the circuit panel down below. So I need room. So what I did is I created 4 inches of space behind it, and it happened. And the reason I chose 4 inches is because that's how much clearance I need to slide them pieces of conduit in. Because I'm going to add more to the shop, right? So instead of having it screwed to the wall, it was like screwed right there, and I had a screw in there. I needed some space, so my solution was this. So these are braces that go down to the floor, okay? And I've got, down the row, I've got braces, and these braces are for that 4-foot knee wall. You can see how the braces intermix with my junk. So I took a 2x6 and I leveled it up, okay? And I put screws on the end, probably in the dark, but I got 4 screws I pre-drilled on the end there. And yeah, I'm covering up my tag a little, but I know what's on it. So I created some space behind it, 4 inches of space. So now I am free to add more penetrations for conduit. And if you haven't figured it out, the other panel is going to sit next to it, right? I'm going to have, there's one that's currently hooked up to my motor. The other motor I might stick underneath there. I might put it in with these air tanks. And with the other North American converter panel there. Now, let me show you. I know, this is just... Alright. So, as you can see, and I killed the power, folks, if the breaker's off. This is incoming power from the breaker, okay? And this is the motor. This goes down there, you know, to the motor. I did run extra grounds to the motor. I didn't want to rely on the flex. See, what I did is I just stubbed out and I converted to seal tight flex, and I just go into the bottom and it's right there. And I'm glad I didn't hard conduit run this, because it was on the wall and I put it over here. So this is the push button. This is that irrigation wire. I think it's like 18 gauge solid wire or something like that. But that's what it looks like hooked up, an identical panel. So what I'm going to do is this. That end contact, you can see the starter wire. This is an auxiliary contact that is an accessory to this contactor relay. So the lower terminals down there are normally open. And when this activates, it's the hold-in coil for the push-button circuit. So now that's not used. These two aren't used up here. Those are normally closed. No. Am I closed? Yeah, normally closed. So what I'm going to do is I'm going to run the starter switch just like I normally would here with this extra wires going down to the button, the starter button, and I'm going to run the start capacitors on the opposite phase converter. Okay, so the panel that's going to be over here, I'm going to take the relay for the start capacitors on the other one and run it through the contactor, auxiliary contact normally closed here. So if I go downstairs and I press the push button and this is not on yet, okay, since this is normally closed and this is off, this is not started yet. Since this is normally closed and it's not started yet and this is in the off condition, this will allow the other one to start, and the contactor, the main contactor, will energize and bring in the motor, and it will also allow the start capacitors to operate in the other one. So what the deal is, if this one is running, let's say I start this one first, and this starts up the motor. It brings the motor into the circuit, and this starts the motor. Now that this one's on, this is now broken. These contacts are now broken because it's in the on condition. It was normally closed, and now it's open. So if this contactor is energized, it inhibits the capacitor start on the other one. So if I turn this one on, it starts up, this starter relay works, and the starter and the other one is now inhibited. If I start the second one, it's just going to pull in the main contactor, and because it's inhibited by this one, it's going to just, you know, it's going to start the second one without the starting capacitors, because I've already got this one generating the third leg. I'm generating 2 more phases. So if this is running and I bring this one in, it'll just energize it into the circuit without the start relay, without the start capacitors coming online. Okay? Because you don't need it. You already got 3 phase coming out of this one. You're just bringing this in, and you're going to be bringing this in for additional horsepower capacity. So it's going to be bringing in another breaker line of L1 and L2, and you've got the blue wire is the third leg. So you've got L1, L2, and then the third leg. So if you've got 3-phase power already from the first rotary phase converter, and it's just going to come in and start up the second one. Now I'm going to do, on the second panel, I'm going to do the same thing. I'm going to take this start capacitor control relay, and it's got white and black wires. I'll take one of those and run it through the auxiliary contact on the other phase converter panel. So if the other phase converter panel, number 2, starts first, and then someone brings in this one second, the other panel is inhibiting the start relay on this one, and it'll just energize the relay and bring in the first rotary converter motor. So I got it kind of figured out. It's nice that auxiliary contact exists. So I'm going to have 2 start buttons downstairs, folks. And if you start one, it'll start with the capacitors. If you start the second one, it'll just bring it up to speed. And if I start the second one first, it'll start with the capacitors. And then if I bring in number 1 here, it'll just start without the start capacitors, because there's already 3-phase being generated by the other one. So I hope you guys followed all that. So I've been sweating myself silly up here, and I got my board in there installed, leveled up, and back up here. Yeah. So that's going to work wonderful, and I'll have room for my conduit, nice and neat, and I've got my conduit going around the corner here. I think one's for some outlets across the other side of the opening, and one's for air conditioning. So I made shelves over there on all the bracing for the knee wall, and I got some stuff stored there. I got extra motors, and I got a lot of parts, a lot of supplies, wire, you know. It's Doozer's supermarket of stuff, and it kind of dwindles out. This is like 40 feet long up here. and I got the window down there. I got my, the blue things are just pieces of foam on the rods. So there's a beam down below hanging off them. Those are 5/8 B7 rods. And I don't know if I can show you. I got a little scuttle hole winch. That's a winch for lifting. I got it plugged in just up the scuttle hole. That's how I got up here. And I don't know if you can see. There you go. I made brackets to hold. So the ridge beam, the ridge board is actually a 2x12. Okay. The ridge board's a 2x12 with anticipation of. I know you can't see it. It's too dark, but it's just a U-shaped piece of flat iron, and it's bolted through. This one is a bit different because I had a rafter in the way. I had to fabricate a split bracket. Okay, I had to make one that went around the rafter on either side. So it's kind of neat. There's a better shot, and there's just a nut on the inside holding the rod. You know, there's a nut up inside there, a 5/8 nut. So that holds the rod. And I gotta sweep my floor. But anyhow, that's what it is. And like I said, more stuff. I got empty oil drums that I'm gonna fill up because I gotta drain 30 gallons of oil out of the Rockford planer. Oh, James at Engineers Workshop was asking me about a compressor, and we're kind of talking about something. This is my compressor. This is I think it's an 80-gallon tank. It's an M Glow. Johnson City, Pennsylvania. This is 16.8 CFM at, I think, 90 PSI. 4-cylinder single stage, okay? And there's the motor. I took the motor and the compressor head off just because it was lighter. Not a huge compressor, but definitely, you know, 4-cylinder, single stage. A lot of them are 4-cylinder 2-stage, and you can get up 175 PSI. This one will only do 120, but dude, who cares? 120? I got it regulated down to like 95, 100 anyways with the regulators. But, you know, I got real deal start contactors and automatic drains and everything. There it goes, M Glow. I forgot that was on there. And since I brought the tank down here, I've treated it. It's a real deal 1/4-inch tank. There was some rust in the bottom. It's not that old. It came out of a dentist's office. There's some rust inside, just flaky rust. I filled it up with a couple gallons of phosphoric acid and treated the inside with phosphoric acid. The thing was really not used that much. And I know compressor tanks explode, but this one, I assure you, is in good condition. Don't worry about me blowing myself up, and if it is, it's my own stupid head that did it. And I got, these are, I think these are 20-gallon tanks. It's funny, these are Matrix Medical tanks for dental air compressors. And this M Glow was also used in a dental office. And these Matrix Medical tanks, if I hook everything together, and I got hoses and fittings all set up, it's another 60 gallons, so I got 120 gallons total capacity with all of it. So I need to hook that up. Like I said, it's 4-cylinder single stage. It does really well for me, but you know, whatever. I just kind of came onto a deal with it, and it seemed to work so far. I got some lights put up. 4-foot fluorescents running the LED bulbs. And I got more to put up. I'm going to put up another 6. I'm just going to take the ballasts out and just run LED bulbs. With these ballasts, they need rapid start bulbs, and I just had regular bulbs, and they wouldn't start half the time, and it's a huge pain in the butt. Anyways, what else while I'm up here? Craftsman radial arm saw I bought for $10 at the Habitat store. Never been basically used. I think that's a late 60s model. Perfect condition. This, I don't know if you can see it. It's a drill press. There you go. It's a Hamilton high-speed drill press. And it's in fine condition. I think I bought this off a buddy of mine for like 50 bucks or 30 bucks, I don't remember. But it's got a lot of mechanism, and it's perfectly smooth. And one of these days I might rig this up on the bench next to my Atlas drill press, my little small one. So that's cool. There's a Matrix Medical spit sucker vein pump. That's a spit sucker, for lack of a better, you know, that sucker thing they put in your mouth. KX250 dirt bike. I got it because I built my Super Bronc copy bike, which I've never showed you guys. It's got inverted front suspension. Can you see the inverted forks? And disc brakes. I used one of these bikes to build my Super Bronc bike, and this one I seen on Craigslist. I think I paid 50 bucks or 75 bucks for this, and I got it just because it was identical to all the parts that I have on my other bike. So yeah, spare parts. Lots of shelving. Lots of shelving. I've got the stanchions. This is just regular gray shelving. That's the white stuff is supermarket shelving, and I've got the stanchions for that too. I just not had a place chance to put it up. So that's kind of it. Getting free alcohol, not the drinking kind, the solvent kind. Spare headstock for the Brown & Sharp 13. I got that from J&M Surplus on eBay, Jason Machowski. So that's going to get the Harding 5C spindle. All the yellow bits are parts from a, I think it was a Czechoslovakian copy of a Cincinnati No. 2 tool cutter grinder. Okay? These are spare spindles for the Brown & Sharp 13. I got 3 ball bearing spindles and 1 plain bearing spindle. That's my second with the handle on top. I just put a wire handle on it. That's an end mill sharpener that came with the Brown & Sharp 13. I got 2 of those. Hold down clamps. I think those are Carver, made in England. Carver hold down clamps. Those are really cool for the horizontal, for any milling machine, but I'm going to use them on the horizontal boring mill and the planer. Collets and other end mill sharpening. There's a backing off fixture. There's a radius relieving fixture for putting round noses on end mills. It's in there somewhere. Toolboxes, carburetors, just, you know, I got the wire out, just everything up here. But I'm going to go downstairs because it's like 97 degrees in Charlotte today. It's really hot. So let me just go downstairs. That was my phase converter. And that's what I've been working on. I'm going to set that second panel up there. Start getting it wired up.